All right, so you're interested in AI code generation.
Uh-huh.
Specifically, how reinforcement learning is being used to improve large language models,
Right.
the ones that write code.
Yeah.
We've got a fascinating research paper to unpack here.
Really interesting area.
Yeah.
I mean, we're moving beyond teaching AI to just write code that looks right. We're talking about code that actually works.
Exactly, and that's a much tougher challenge.
Yeah, and works well.
So how do you actually teach AI to write good code?
Yeah.
Well, this paper, ACECODER, ACECODER RL, via automated test case synthesis, might have the answer.
Yeah, the research team behind this,
Okay.
folks from the University of Waterloo,
Wow.
HKUST, an independent researcher, and Netmine AI,
Okay.
have come up with a pretty clever system.
Interesting.
They're using automatically generated test cases,
Oh.
almost like a coding exam,
Okay.
to guide AI models towards writing better code.
That's intriguing.
Yeah.
But before we get into how it works, I think it's important to understand the problem they're trying to solve.
Okay.
What makes reinforcement learning and code generation so tricky?
Well, there are a couple of big hurdles.
Okay.
First, unlike something like math, where there's a clear right or wrong answer,
Right.
it's harder to give AI a reliable reward for generating code.
I see.
You can't just look at the code and know if it's good. You have to actually test it.
Right, because code could look perfect,
Yeah.
but fail in certain situations.
Yeah.
Or be inefficient.
Exactly. And that brings us to the second challenge,
Okay.
the lack of large coding datasets with reliable tests.
Uh-huh.
Existing datasets often depend on human-created tests,
Yeah.
which are time-consuming and expensive to make.
Right.
That limits how much data you can use to train your AI.
So you need good test cases to train an AI that writes good code.
Yeah.
But you also need good AI to help generate those test cases. It sounds like a classic chicken and egg problem.
It is, and
Yeah.
that's where ACECODER comes in, with a potential solution. Automated test case synthesis. They're essentially taking existing code data sets
Okay.
and using AI to create a bunch of new test cases,
Okay.
turning them into LEET code-style challenges.
Wait, so they're using AI to generate the tests that will then be used to train another AI to write code.
You got it.
Ooh.
They used GPT-4o Mini,
Okay.
which is a pretty powerful language model,
Oh, wow.
to understand the code and then come up with new coding problems and test cases.
Clever. But I imagine there's a risk of the AI generating test cases that are,
Sure.
well, a little nonsensical, right?
Yeah.
We all know AI can sometimes hallucinate a bit.
That's absolutely a concern.
Yeah.
To weed out those unreliable tests, they used another, even larger language model, Qwen 2.5 Coder 32B Instruct.
Wow, okay.
This model generated its own solutions based on the coding prompt, and they used those solutions to figure out which test cases made sense and which were bogus.
Okay, so the AI is basically acting as its own quality control checker.
Exactly.
Interesting.
They also set a minimum bar.
Oh.
Any question had to have at least 5 surviving test cases after this filtering process. This ensured quality and helped avoid situations where the AI might be learning from contradictory or confusing tests.
That's really smart.
Yeah.
So they've tackled the test case problem.
Right.
But how do they actually use these tests to teach AI to write better code?
Well, they've developed a specific reward model called ACECODE RM that learns to distinguish between good and bad code based on how each piece of code performs against these test cases.
I'm all ears. How does that work in practice?
They use a system called preference pair construction.
Okay.
Imagine you have 2 pieces of code trying to solve the same problem. ACECODER runs both through the test suite.
Okay.
The code that passes more tests is considered the positive example. The other is the negative example.
So it's almost like a head-to-head coding competition.
Yeah.
Where the reward model is learning by watching which snippets consistently win.
That's a great way to put it.
Yeah.
And they use a statistical method called the Bradley-Terry model
Okay.
to actually quantify this preference and train the reward model.
So instead of explicitly telling the AI what good code looks like,
Right.
it's figuring it out through these coding tools.
Yeah.
I like it.
Yeah.
And they've built different versions of this reward model based on different large language models, right?
Yes. They have ACECODE RM7B and ACECODE RM32B, with the B standing for billions of parameters.
Got it.
Which is basically a measure of how complex these models are.
Okay, so we've got the scene set, a tricky problem,
Right.
a clever solution, using automated test case generation,
Yeah.
and 2 powerful reward models ready to learn.
Yep.
Now, the big question is, did it actually work?
Well, that's where things get really exciting.
Okay.
And to answer that, we need to look at how they put ACECODER to the test,
Right.
which we'll get into right after this.
So let's talk results. Did it actually work?
Like you said, it's exciting stuff. One way they tested this was using a technique called best of n sampling.
Okay.
So the AI generates multiple code solutions for a problem, and then the reward model steps in and picks the one it thinks is best.
Okay, so it's like the AI is brainstorming different approaches, and the reward model is the judge.
Exactly.
Picking the most promising solution.
What they found is that when ACECODE RM was used to select the best solution, it led to some pretty big performance boosts.
Not just like minor improvements.
No, we're talking significant jumps.
Wow.
Like, in some cases, models saw their ability to solve these complex coding challenges increase by over 10%.
So ACECODER isn't just helping AI write code that's slightly better.
Right.
It's enabling them to tackle problems they couldn't solve before.
Exactly. And here's the really impressive part.
Okay.
They tested this with a variety of different large language models, not just the ones they used to create the reward model.
So it's not limited to specific AI models?
Right. The results were consistent across the board.
So this technique has the potential to be widely applicable.
That's what it looks like.
Were there any results that were particularly surprising or stood out to you?
One thing I found interesting was the impact on smaller, more accessible language models.
Okay.
For example, they saw significant improvements with a model called Llama 3.18b-ins.
Okay.
Which is relatively small compared to some of the giants out there.
So ACECODER is not only making the best models even better, but it's also helping to level the playing field.
Yeah.
Allowing smaller models to punch above their weight.
It's all about making this technology more accessible.
Right, and broadening the potential applications.
Exactly.
It makes a lot of sense.
And, even the more advanced models designed specifically for code generation, like Qwen 2.5 Coder 7b-ins, they still saw improvements.
So even the state-of-the-art models benefited?
Yes, suggesting that this technique is tapping into something fundamental about how AI learns to code.
Fascinating. Now, best of n sampling is only one way to leverage this reward model, right?
That's right.
They also used it for direct reinforcement learning.
You got it. And that's where we see the potential for even more dramatic long-term impact.
Okay.
With reinforcement learning, the AI is learning from its own actions.
Okay.
Constantly receiving feedback and adjusting its strategy.
Kind of like how a human would practice and improve over time.
Exactly. And what's remarkable is that they saw consistent improvements using ACECODE RM for reinforcement learning.
Wow.
Across all the benchmarks they tested.
So even without the benefit of multiple tries and picking the best one.
Yep, even with just the single attempt at generating code.
The AI was writing better code thanks to this reinforcement learning approach. What were some of the key insights from those reinforcement learning experiments?
Well, one thing that stood out was how quickly the AI was able to improve. Even with a relatively small number of training steps, roughly 80, they saw significant performance gains, especially when starting with a base model like Qwen 2.5 Coder 7b base.
Hold on. So not only can this technique improve existing models that have already been fine-tuned, but it can also accelerate the training of new models.
That's the implication. And it's huge because training large language models is incredibly computationally expensive. So if you can achieve better results with less training, that's a game changer.
Absolutely.
In terms of efficiency and accessibility.
That could really democratize this technology.
Yeah.
And open up new possibilities.
Were there any other findings from the reinforcement learning tests that you found noteworthy?
Yeah, there was one other experiment that I thought was really insightful. They compared their specialized reward model, ACECODE RM, to some of the top-performing general-purpose reward models. The kind that are designed to work across a wide range of tasks, not just code generation.
I would imagine that a reward model specifically trained on code would have an edge.
And that's exactly what they found.
The general-purpose reward models were actually pretty bad at evaluating code.
Oh, really?
Yeah, they often failed to identify the best solutions, sometimes even performing worse than random chance.
So it seems like having a reward model that truly understands the nuances of code. What makes it good is essential.
Absolutely. It highlights the importance of domain-specific expertise.
Even in AI.
Yeah.
Okay, We've covered a lot of ground here.
We have.
We've talked about the challenges of AI code generation, the clever solution proposed by ACECODER,
Right.
and the impressive results they achieved across various tests. I think it's time to bring it back to our listener.
Okay.
And synthesize what we've learned. What are the key takeaways from all of this research?
I think the biggest takeaway is that this approach of automated test case synthesis is a powerful tool for pushing AI code generation forward.
Okay.
It tackles two of the biggest hurdles in the field, the lack of reliable reward signals and the scarcity of large, high-quality coding datasets.
It's like giving AI the resources it needs to not only write code, but also understand what makes code good.
Exactly. And this leads to the second major takeaway, which is the incredible potential of reinforcement learning in this domain. By combining automated test case generation with a reward model that learns from those tests, we're essentially creating AI systems that can not only write correct code, but also write code that is more efficient, more readable, and potentially even more human-like.
So we're not just talking about automating tedious tasks.
Right.
We're talking about creating AI that can truly collaborate with human developers.
That's right.
Helping us write better software and push the boundaries of what's possible.
Exactly. And that brings us to why this research is so relevant to you, our listener.
Okay.
Just imagine a future where AI can help you with those basic coding tasks, like writing boilerplate code or finding bugs, but can also go further tackling complex software engineering challenges, working alongside you as a partner, understanding your intent, and even learning from your feedback.
A future where AI helps us unlock new levels of creativity and innovation in software development. It's a future that feels a lot closer thanks to research like this. But this isn't just about making coders' lives easier.
Right.
It has much broader implications.
Yeah.
Right. Yeah, think about like healthcare, finance, transportation, like all the industries that rely on software.
Oh, yeah, totally.
AI that can write better code could lead to breakthroughs in all these areas, potentially even solving some of the world's biggest challenges.
Yeah, it's really a paradigm shift.
It is.
We're moving from a world where AI is primarily a tool to a world where AI is a collaborator, a partner in problem solving.
Yeah, it's exciting.
It is.
And a bit mind-boggling to think about.
It is.
We've talked about ACECODER's potential to improve code quality and efficiency. But this research also brings up some really interesting philosophical questions about the nature of coding itself.
Yeah.
What really stood out to me was their finding that the best results came from training the reward model on code that had already been filtered by another AI.
It's like having an AI apprentice helping to train the AI master.
Yeah.
And it makes you wonder, like, what does it mean for code to be good in the first place?
Right.
Is it simply about passing the most tests, or is there something more to it?
Yeah, it raises the question of whether AI could actually help us define those less tangible qualities of good code, like elegance, efficiency, and readability.
Right.
These things are hard to quantify.
They are.
But they're so important for human developers.
Yeah, it's fascinating to think that AI might be able to not only recognize these qualities, but also teach them to other AI. It could change the way we think about code and how we evaluate it.
It really highlights how this research is about so much more than just building tools. It's about expanding our own understanding of coding, pushing the boundaries of what's possible.
Exactly. And it's not just about the present, it's about the future.
Yeah.
Imagine AI that can not only write code, but also generate new ideas, design innovative algorithms, and even push the very limits of computer science itself.
It's a future filled with incredible potential.
It is.
It's exciting, it's daunting, and it's certainly something worth pondering.
So to our listener, we leave you with this final thought.
Okay.
How would you use this technology? What problems would you solve? What new possibilities would you explore? We'd love to hear your thoughts.
We began this deep dive exploring your interest in how reinforcement learning could impact AI code generation.
Yeah.
This paper on ACECODER gave us some really insightful answers.
It did.
And more than that, it sparked a whole new set of questions about the nature of code, the potential of AI, and the future of software development. We hope you enjoyed this journey of discovery as much as we did.
I did, for sure.
Remember, the most profound answers often come from unexpected places. And sometimes the best questions are the ones we haven't even thought to ask yet.
Right.
Keep exploring, keep learning,
Yeah.
and keep questioning. That's what the deep dive is all about.
Yep.